the machine learning sessions that I completed on the weekend in the month of June?
No, not that.
Okay. All right. So while we are here, why don't we introduce ourselves? I'll introduce myself. My name is Auditro. Um, it's a very quintessential Bengali pronunciation. I'm sure you would have guessed. I'm actually a Bengali. I work with American Express based out of Gurgaon, and it's been 12 years since I started working in 2008 in the field of data science and analytics. My initial days were spent with Wipro and HSBC before I moved to Amex in 2009. There was a brief period of time when I left the company to explore other avenues. That's been an immensely learning period for me because I ventured out of banking for the first time. And that's when I kind of explored things like insurance as a domain, how modeling can be done in that domain, and how it all adds value. Then I came back to Amex in 2015 and I started a new team for a specific portfolio for marketing analytics. And then after that, this is currently I'm running my second new team in Amex. It's been a year now. My current focus is towards optimizing sales performance by way of measuring how much what's the level of performance of the team, and then
Hello?
calling out insights that can enable them to take their reach their targets better, and then drive growth in the business.
Your voice is breaking.
So guest topics on machine learning. I take the sessions on. My voice is breaking. Okay, is it better now? Is it okay? Is it better now?
Yeah, but
Better. Okay. I don't know. Yeah, till which point you was I audible?
I mean, it was breaking in between. I'm not sure.
Yeah, you
Breaks in
continue whenever we are feeling we will tell.
Okay. Okay. So outside of outside of being curious about various topics on machine learning, yeah, I take an active interest in reading crime novels. I've grown up on characters like Sherlock Holmes, the famous Satyajit Ray, hailing from Calcutta. The different detective novels that continue to interest me. That's what I like to do, and I get some free time nowadays, which is very rare, by the way. And the other important thing, I'm sure you're hearing her from time to time. She's going next to me. She's spending time with my baby daughter. It's interesting. So, well, I think we're probably now full audience. Okay, so welcome to this session. We are going to talk about telemarketing prediction. So it's a case study in which we are enabling the telemarketing team of a bank in order to optimize their personal loan or term loan deposit campaign. So what they want to do is they have to reach out to various clients and customers in order to figure out what kind of customers are likely to sort of take up the term loan, and then based on the model, there has to be some sort of strategy devised in order to enable prioritization. So before we get into the topic and we get into the details of this, why are we doing this? What is the motivation of this project, and then how is it going to be structured? Now, I'm sure like after your curriculum on stats and machine learning is over, what I feel is most important outside of the certificate that you guys will earn, the portfolio that you can develop right on data science projects, and that can add immense value in your resume. So when I team as well as firms, whenever there are requests for what for, it's not that big certificate that's there, but other certificates also, like certificates are one thing. The other thing is having a strong project portfolio that kind of talks about how the candidate has been able to select a few projects. What is the depth of thinking? How much can the candidate think in terms of strategic thinking, right? Can the person bring to the table? Because it's not always about just looking at the data. and then acting on a certain piece of advice, and then building a certain specific machine learning outcome. Sometimes it's about, sometimes it is also about looking at things, exploring the outcome, and then using the machine learning outcome to come up with a very I would say simple but very strongly articulate way for the business to derive value from, right? So the business, um, whichever business you're working with, they need to be able to understand what you have done, number one. Number two, they need to be able to convince themselves that they should be using, they should be ideally using your recommendations in order to improve on the current scenario. So these two things, if these two things are successful, then a data scientist is successful. Otherwise, from a technical perspective, there are a lot of solutions that will go unnoticed. There are a lot of solutions that will just be there and not get implemented because people simply don't understand what went on. And then how can they benefit from this? These are two questions that senior leaders from the business will always have in their mind. Like, do I understand what has been done? That's one part. The other thing is, if I if I got do I understand how I can benefit from this? These are two questions, the most important two questions. And in my opinion, it comes through practice. My voice is breaking, is what I'm getting as a message. um, Let me just make the internet connectivity is okay, but it is in between. Okay. I guess there's a little bit of an issue with the internet. Maybe even not, I think the last time I checked, yeah, it says it's unstable. How do I? Is there a way to connect through the phone? There should be a way
Yeah,
to connect
you
through the
can
phone as well.
you can connect via hotspot.
Okay, somebody is writing something on the screen. I don't know what is happening here. Anyway, so I'm going to dial back in by connecting on this. Yeah, okay. So I'll dial back in through my phone. Okay, guys, I'll be right back. Uh, People, can you hear me now? The issue is, it looks like the phone, I have to call on a number and then use the passcode. I don't have that option on my phone. I can I can at best be connected through the computer, because in the office the WebEx actually um, comes with the option of the WebEx dialing me in.
It's clear for me.
It's clear for you?
Yeah.
Okay, I guess what I'm going to do is maybe reduce my rate of speech. I think that will be of help. Um,
And now it is very clear.
It's better now. I think you can continue. Let's see how it goes.
sure. And I think I will consciously reduce my rate of speech so that even if there are words in between. Okay, I think I'm just gonna go to the other room and leave my baby with my wife. I think
Sure, sure.
check. Allow me a moment. Okay, I'll be right back. I'll be right back.
Sure.
Hello, guys. How's the audio now?
Yeah, it's better.
It's good now, sir.
Okay. In order to reduce the disturbance, let's see. Just it should be even better now. Just switch off the AC. Okay. All right.
We
So
can.
without any further ado, let's begin. I apologize for the initial hiccups. So as I was saying, yeah, there are like, in my opinion, like in my observation, there are two attributes which kind of defines the success of a data science project. One is, of course, the accuracy with which we develop things. The other one is how we try and articulate a problem, a solution actually, so that the business is able to get a clear roadmap on how they can implement it. Like there are, of course, there are many ways in which machine learning models can be deployed. Like there are, you know, pretty automated ways of doing that also, but you have to understand that, for that to happen and for that to be understood and implemented, people have to be quite tech savvy, and quite often you might be working with the business folks who are not either quite tech savvy, or maybe they are doing it for the first time, so they are like, taking it as a learning experience, or they're like experimenting with data science. It can happen, right? For example, and this is what I realized when I joined back Amex in 2015 December. My role moved from the core analytics team to a new business team, and over there we had to set up a new team doing analytics and machine learning. And the challenge we faced was that now we are dealing with marketing VPs and directors, etc. So they have done a lot of, they understand the marketing jargon, but they don't really they pretty much know, right, what, so they want to do cross sell, but they don't wouldn't be aware about all the technicalities behind a response model. So this is the challenge that we ran into, and that's when, I mean, there was a big learning experience. And what I am trying to share with you is a very simple way in which we can use a data set available to us on the internet, and then solve a project. And then when we include this in our resume, we go equipped with not just a solution to talk about, but each of us go with at least one suggestion as a strong recommendation from our side, had we been a data scientist working on a live project like this. Okay, so if this was a very live scenario, what are some of the things that we could have done? Obviously, there will be something left on the table because the data is not fully complete, and I'll tell you why. But whatever we have, if we start working with it, uh, from 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 building a solution with a machine learning approach towards carving out a recommendation. So we will complete that journey. So the way I'm going to structure this session is basically in two parts. In all the project sessions, it happens in two parts. The first part, we discuss the problem, the data, and we discuss one approach which we can take towards solutioning of this problem. I'll be sharing with you the location of this data, also the deck here. And then when you look at the data yourself, you might want to play around with it over the week, and then maybe try and come up with your own solution based on the approach outlined here. Because in the next week, we will come back, revisit this problem, and purely, so I'm going to use like Python to come up with a solution of my own, and then take the solution from Python, go to Excel, and then really carve out a comprehensive articulation
Yeah,
strategy.
is this a Kaggle project?
It is a Kaggle project, but if you go to Kaggle, there are many solutions out there. But what happens is, most of the solutions, they they would try to like finish at the point where they measure the accuracy in the test data, and then that's it, right? So they would kind of say that, okay, this is the leaderboard score, this is the accuracy. So it's all about how accurate the model is. Of course, that is a given thing, it is a necessary condition.
No, actually, I am also simultaneously want to build my profile on Kaggle. So I was just wondering if I could side by side, work on this project
Mm.
on and submit it on Kaggle. So can you
No.
share the link of this data set?
Yes, it's also on Kaggle, but it's not a live project anymore. So I have taken it from UCI data repository. I will share it with you. So that's there. The idea is that, when you include this in your resume, how do you position it? So all of you should we feel very confident about saying that, okay, this is a project I've worked on. it is not just about applying a machine learning concept. Understood the business problem, looked at the data, understood my limitations, explored my options, created a solution, build my recommendations. So that's a complete end-to-end journey. Okay, so with that, let's look at the problem statement. Now, the problem statement, purely from a data science perspective, is to simply, adopt a data-driven approach towards building a model, and then that should predict who's gonna give a, who's gonna be accepting a term loan if you call them up and try to sell a personal loan or not. And even in the current context, like if a project like this can attract the attention of, say, Indian data science players, for example, like Bajaj FinServ. Yeah, they do very good data science. I think they're based out of Pune. I think Bajaj Finance also does. So Reliance is also getting heavily into data science and machine learning. So they are also going to do. There's Geo coming up, which is coming up in a huge way. So these guys can be interested. Most of the banks, for example, Axis Bank, I think HDFC also has their own analytics. SBI Cards is a great place to build your career in Indian banking analytics. So these are places where personal loan campaigns have, I'm sure all of you would have got calls at some point of time. So this is a very relevant topic for them also. Okay. So does that make sense, guys? Does it sound like an interesting plan? Or if it's, I mean, we're going to have a project session every Sunday. So it's going to be divided into two parts. First part is about approach and theory, and the phase 2 will be on the implementation. Does that?
Sure. Yes, of course.
All right. So what we want to do over here is, and the statement that I've come up with, this is my own, I'm statementing the problem on my own. I'm saying, how do I enable the telemarketing team to prioritize targeting for a term loan marketing program? There's a term loan marketing program going on. I only have so many people in my telemarketing team, right? I do not want to spend a lot of money and then hire people outside, from outside, doing on a contract, and then make everybody call everybody up. So I would want people to prioritize, so that my initial whatever money and time and resources I spend, I get the maximum bang for my buck, right? And how do I enable them? I will adopt a data driven approach. That's my statement. Okay, now this is where I'm outlining the data source and objective. Now the data set is based on banking marketing data set on UCI data repository, right? So the full description of this data set is available in this link. So if you happen to sort of go to this link, um, you can actually go there. And I think people have taken this data set and they have uploaded it on Kaggle. Okay. Now, this is actually, if you see this, this is related to direct marketing campaigns of a Portuguese banking institution. Okay, so why is this relevant not only from a business point of view and the present context point of view, because term loan calls, we do get term loan calls, but also from a real life scenario perspective. So if you think about it, I mean, it is really very closely, the data very closely resembles of the actual marketing data. It's a very direct marketing campaign. Now, in the age of email marketing and other forms of marketing, right, through apps and through banner ads, there are different channels that have come up through the internet. But having said that, telemarketing as a channel still exists, as long as we're not sending offers on mail or by post. So telemarketing, we do see telemarketing still to be a very relevant channel. So that way also, from a relevance point of view, this is a good one to work on. Now it has a few social and economic attributes which has actually enriched the data set. Now, because like I said, it's not complete, as I said earlier, it's not complete because of confidentiality causes. Now this data set actually is taken from a Portuguese bank, as I said, but uh, they've tried to keep it as real as possible, but they haven't really revealed all the attribute. The other option was to give us maybe um, sort of masked data, or say scrambled data for those attributes, but that would have reduced the how would I say, I think, the authenticity of the data to some extent. So in order to make sure that the data continues to stay authentic, they rather chose not to give us the attributes for confidentiality, and then reduce some of the dimensions in the data, but that should be okay. Our goal is that there is a variable or a feature given to us for term loan deposit. Our objective is to build a binary classification structure. So this is a very standard problem from a machine learning perspective, but we will look at it in three ways. Okay, so now what I would like to do is walk you through what we have in the data set, so that we are like, more, I have a good glimpse of what we have in this entire data set. We've got age of client or customer. We've got the job. Now this is an interesting variable because it has different categories: admin, blue collar job, entrepreneur, housemaid, management, retired, services, student, technician. So these are different categories under job. There are 2-3 things you can do, like, you can straight away go for one hot encoding and you can create indicator variables or dummy variables for each of these categories. Or you might want to see if it kind of makes sense to group some of these with respect to your event rate. Yeah, those are things we'll discuss later. But yeah, this is a very, very interesting feature. Marital status of the client, then education. Is it a basic 4 years, basic 6 and up to 9 years, right? Then high school, has no education at all. There's a professional course that the person has done, university degree, and then unknown. So again, education level, multiple levels, categorical variable seems like an interesting one. Default. Now, although this data set is not meant to be used for risk purposes, why this variable is there is interesting. So let me, I will take a couple of steps back and then come back to this. So whenever we kind of start working on any problem, try to think of it in 2-3 different dimensions. Yeah. So this happens to be a marketing problem. You're trying to be very, very strategic in enabling the telemarketing team, right? Now, what is closely related to the product that you are trying to sell? So if you think about it, a behavior that is very closely related to the product is the risk, because ultimately what you're selling in this case is a loan, right? So what can happen is that either the loan can be paid back or the loan won't be paid back. So before you, as a marketer, decide to reach out to a person, you would want to have some understanding of the person's credit risk, right? Some understanding. So for banks nowadays, I mean, in our context, there will be like, CIBIL score. So for India's context, there's CIBIL score that we look into. And then CIBIL is like, again, it's a credit score, but the purpose is the same. How do people assess whether it is even safe to give you the product, right? That is because there's a lot of money wise risk involved. Now, if you think about it from a
Hello.
traditional marketing perspective, sorry, yeah, please go ahead. Hello, any question?
No, please go ahead.
Okay. At any point of time, guys, if you have any questions or if you want to elaborate on some point that I'm trying to, I'm trying to make, or if you have additional context on some of these points, please raise your hand. Please feel free to, interrupt me, and then, we can carry on the discussion. So I highly prefer these sessions to be more in a discussion mode, and then, feel free to come up with your own thoughts if you, as in when you feel so. So yeah, so don't hold yourself back at all. All right. So as I was saying, when we think of marketing, right? I was When I was doing my MSc in statistics from Delhi University, the fact about all these academic courses is that there's not a lot of business context that you learn out of these courses. There's a lot of, technical skills you pick up, definitely, but not a very business oriented sort of thing. Now, because of my curiosity, I kind of kept on picking up books on marketing research, this, that. So I kept on reading. So I came across a term called relevance marketing. So now, why is it important? It kind of stuck with me because in all the different marketing campaigns that I've analyzed and I've tried to, create the next, targeting strategy, we had to make sure that one thing is like really important is that, your audience has to be relevant. right? It has to be relevant from a need perspective. The audience must be having a need for the product. Also, it has to work both ways. It has to work for the client or the prospect that you are trying, who you want to sell out this particular product, and also as a business, it has to work for you. So that is why when we think of a product like a loan or a credit card or anything to do with money wise credit, it has to work both ways. It has to work both for the bank as well as for the particular client. So there has to be a need for credit firstly, and then secondly, it cannot be so risky that the bank is like, okay, I pretty much know this guy's going to default, but who cares, let me just make sure I just sell the loan, because as a sales executive, I'm going to get incentives. So you have to keep in mind that your sales people are going to, come to you and say, okay, I've met my target. These are my number of loans I've sold. And so this is my incentive that I kind of, calculated, and then you have to pay them. So if that is the kind of scenario, obviously it's going to harm the bank more than anything. So as data scientists, we have to be very, very careful that do we have all the necessary ingredients to build a strategy. So now risk is a very important ingredient in this context because of the fact that we are trying to market a loan product. That's why risk is important. If we had tried to market, say, an insurance product, then risk is important, but not credit risk. Those are event risk. So for example, if I'm trying to sell a car loan, sorry, a car insurance policy to a person whose car insurance policy is about to expire in a couple of months, but I did not even check how many accidents the person has gotten into in the last 2 years. That is incorrect. I should be checking it, because if I don't do it, I will not get a sense of how much, what's my insurance risk for that particular customer. So what I'm trying to say is that marketing and risk, whenever you're trying to market a product, you have to assess what is the, under what circumstances you will be on the losing side. So do you have enough data so that you can strategize yourself against being on the losing side? Does that make sense, guys?
Yeah, sure.
Right? So in this data set, we have this variable called default. Okay. Now, why is this a good variable for us? Because it gives us two, three things. One is that it gives us a sense of the credit risk for sure, because this is what I needed, right? To know, am I going to be on the losing side? Now, why this and not something else? For example, we know that number of times you call up a credit bureau to understand, or number of times you inquire for a credit card or loan. That variable is also very strongly correlated with credit risk. So why not that variable? And why this? Now, if you see this outcome default, right? It is obviously a combination of multiple features. How do we know this? Because when we try to build a risk model, we've seen that you cannot build a model with only one feature. You will probably build it with 15, 20, 25 features. So uh, this is an outcome, default outcome. It is driven by it's a plethora of features connected to the client. Therefore, this happens to be a very, very strong candidate for me to assess the credit risk, and also figure out, like, yeah, um, how do I, like, carve out my audiences to go after them. Okay. Then we have, do you have a housing loan? Is there a personal loan going on, right? All these are important to understand, because then is the person, like, how much, already we need to know that, based on, although we don't have income, it could have been nice to see if they have income. But we have default. Now default, we know, is very, very closely correlated to income. So having high default and a housing loan can be a very detrimental scenario. But if you have low default and you have a housing loan, then it is probably not that bad a scenario. Because then if you're not defaulting and you have a housing loan, then this is a serious customer, and most likely going to pay back. Okay. Then contact communication type, right? So what is the way to contact the customer? Either cellular phone, cell phones, or telephone. So some people still have landline phones. So is it going to be that, or is it going to be, like, cell phone? So landline phones are considered to be slightly less risky, because it talks about a permanent address of that person. And if it's just the cell phone, then yeah, it's slightly more risky, but yeah, this almost everybody has that, so it's okay. Then last contact month of year. Now, if you look at the um, the month of the last contact, actually, so last time when the client was contacted, how long, what has been the month? So is it quarter 1, quarter 2, quarter 3, or quarter 4? So if you want to create something like each month's indicator variable, that also you can do, or you might want to combine some months. So it depends on how we explore the data. So I will elaborate on that as we go along. Then day of the week. So when it was last contacted, what day of the week was it? Again, the other variable is duration. So when the last contact was made, what's the duration in seconds? So how long did we speak? See, this is a little bit of a challenging variable, because you see, when you when you're building a solution using machine learning, you have to make sure that when a new observation comes, you are able to capture all the data connected to the new observation and then feed into your model, right? All of you understand that, all of you agree to that, I'm sure. So in this case, if a new observation comes who I have not contacted, the duration will be by default 0, right? But the problem is, we haven't tried contacting this client. What if we actually try and then this particular client talks to us for quite some time? Then I am going to have some number for this duration. Now, if say duration of say 35 seconds means that term loan deposits are actually going to go very high likelihood of term loan deposit, and if the person talks to me for 40 minutes, then by that logic, I should be good. But the only problem is we will not have this data. We will not have duration for new observations. So I would recommend that we don't use this variable, but we can try to see if we can sort of use this to understand that, if we call up this this kind of customer, this profile of customer, if we call up this profile of customer, then how much time can we expect to have a conversation, and does that have a relationship or some sort of bearing on the term deposit? So if a person talks to for say up to 10 seconds, does that mean anything in terms of term deposit possibilities versus 25 seconds versus 45 seconds and so on? You see what I'm saying? But ideally, try not to use this as a independent predictor. Okay, campaign, important. Number of contacts performed during this campaign and for this client. You do not want to have a situation where you're bombarding the same client with repeated campaign calls. It irritates people. So where are we right now? How many calls or how many contacts down are we? We should know that before we decide whether to reach out to a particular client or not. So that's important to know. Then P days. P days is a variable that talks about number of days that passed by after the client was contacted from a previous campaign. So this is good because you need to sort of wait for a few days any which way, but this variable will tell you that how many days are you, like, is it okay to wait? How many days must pass between the last contact and now for things to become positive for term loan deposit? Does that make sense, guys? Any questions so far?
Good so far.
One question now. So my question is regarding high likelihood, you said, right? So why you're going for high likelihood
Okay.
for any variable?
Okay. So when I say high likelihood, I mean, if you go back to the problem statement, you'll see the high likelihood is for whether a particular customer is going to take up a term loan or not. Now, if you today happen to be, say, leading the telemarketing group, and the data science unit from your organization has promised you that they will come up with a list of people you should target on day 1, and then a list of people you should target on day 2, and so on. Now, people you need to target on day 1 are the ones who you know from your data that are most likely to respond or to take up a term loan, right? You want to because the initial days of effort you want to spend fruitfully. So you obviously you might want to, like, target, you do not want to target everybody. I don't have the bandwidth to target everybody. I can only target set 30% or 40% of the data. That's what my bandwidth suggests. but my issue is, how do I cherry pick my customers? Like, how do I choose which one to go after first, which one to go after second, which one to go after third and fourth? That is what I'm talking about. But if you do not look at the likelihood, you wouldn't be able to understand whether, I mean, likelihood itself is going to determine whether you should target or not. Because unless and until there is any chance of the person actually taking up a term loan, why would you even call up that person?
So is it like importance of a variable on a dependent variable? Like we can, is it like a mathematical way to find out importance of a variable?
No, you should just simply interpret the word likelihood as a probability. Okay, so
Okay.
think of it like this: that you're trying to estimate the probability that a person is going to take up the loan, and use the word probability and likelihood interchangeably in order to make sense.
No, my question is, is there a mathematical way we can find out that this is the variable is having high likelihood or high probability of independent variable?
Yes,
Is that a way?
yes, yes. There are ways. So there are ways. Of course, you can find out many things. I would say visualization is one easy way in which you can not only understand but also you can articulate very easily. But from a pure math perspective, I would say you can use information value. A discussion about information value, of course, is beyond the scope of today's class, but what you can do is, I will leave my phone number at the end of it. You can just WhatsApp me. I'll send you a paper on information value, and then it can help you go through it. You can see what it is all about. But that is a purely mathematical way to see the strength of a predictor.
There is a group. Can you put that there, sir?
Yeah, I'll put it on that
Sending.
group. Sure. Which one? The March 2020 group or the April 2020 group?
You can keep in chat itself also. Chat in session itself only.
In this chat session.
Yeah, we can can
No, you
save
can
in our
ask.
mobile.
I mean, if somebody has not joined, they might not be able to get it. You can ask Abhishek. He will add you into the WhatsApp group, rather, I guess. Oh yeah, there are multiple people, isn't
WhatsApp groups. Yeah, multiple.
Yeah, that's why I'm telling for now only you can send in chat. Later Abhishek will be add you.
it?
Okay,
Okay.
I will do that. Towards the end of the session, what I'm going to do is go to Google and share the link.
Yeah.
Uh, you should be able to just go and get a Suji paper. It's a SAS paper, but that will help you understand where I'm coming from. And it's a purely mathematical way of doing it. But it takes a lot of explanation to people who do not understand. I will try to show you a simple visualization that is going to do the same job, but yeah, in a more simple way, in a more explainable way. Okay.
Okay.
Yeah, I have one more doubt regarding that campaign and the P days.
Yeah, go ahead.
Both are same, isn't it? They're overlapping, is it?
No, if you have, say, for the present camp for the for the campaign, if you have targeted called up 5 times, right? Then if, then that is going to be under the variable called campaign. Now P days is how many days have passed by since you last contacted them. So you contacted the person on a previous campaign, and then how many days have passed? Is it like 12 days, 14 days? How much earlier did you call up? So if it is more, right, P days, if the P days increases, it means that a lot of time has elapsed between the last contact made and the contact now. So that way the client is less likely to get pissed off and actually talk to you. But if you start calling them up every week, might just not work for you.
One question here: how is this speed is computed? Because it's a dynamic data. For like today, it might be like 6 days. Tomorrow, if I do, it's 7 days.
Yeah.
So, how is it? Is it a dynamic data? It's a dynamic data. How do we extract this?
Okay, so these data sets, they're actually a pretty good question. May I know your name?
Satyamurthy.
Hi, Satyamurthy. So it's a very good question. These data sets, when they are constructed for any marketing campaign analysis, especially for banks, they are not taken from one source. There's going to be a very well architectured database, and then from different tables within that database, various different informations are going to be housed. Different data points are going to be housed. So you would try to sort of bring all of it together into one master data and then calculate them. So I'm sure number of days that has passed is a calculated field between the last contact date. I'm sure they have captured the last contact date and today's date. So when this data set was prepared, as of that date, there's a date difference that has been taken between the last. So for example, imagine that I am preparing this data set as of 10th of July. Okay. And I last contacted somebody in 10th of July 2020. Sorry, 2019. So now it's 365 days for me right now, 367 6 days for me right now. So I have done that. Now how do I calculate? I basically take a difference of the last contacted date and at the time when I'm making this data set. So whenever say you have this model and you sort of prepare and you want to run a campaign in future 3 months down the line. So after 3 months down the line, whenever you're preparing the data for identifying which people to go after, you need to sort of calculate this date difference as of that time, and whatever value p days can take, your model rules will be applied on those data points, and then you can find out your targets. Does that help?
Yeah, that answers. Thanks.
Okay,
Yeah,
perfect.
I have one more doubt. You said that there will be multiple tables and all, and you'll be
Mhm.
fetching the data. I mean, different features.
Uh,
Who
yeah.
who will decide which are the features? Because if you don't have business domain knowledge, how will,
Mm-hmm.
I
Okay.
mean, in a typical
Uh,
scenario, who does it?
yeah, perfect. I think we are getting seriously good questions in this conversation. I'm really liking the fact that we're having this discussion in this mode. Now, here's the thing. There is no one person or one team that will guide you. I know it sounds very tricky and it's a bit difficult, but it's true. So what you need to do is you first have to browse through various tables that are there. Now, either you can come up with a wish list of features. I mean, that's how I can see some in a real life scenario. You either we can come with a wish list and then go to your leader and say, I have got this wish list of this particular wish list of features. So can you just align? You need to point a person to in my direction so that I can go and talk to that team or that person to take some guidance on which tables I need to go to. So I would say in order to make some initial headway,
I am sorry. Can you repeat? There was some disturbance,
yeah,
internet issue, I guess.
okay. Yeah, so these set of features, right, they are not decided, I would say, pre-decided, so to say. So every campaign or every analysis or every kind of project like this, it would begin with some sort of business hypothesis. So like I was pointing out earlier, that you need to have a sense of risk. You need to have a sense of uh, what kind of clients are you talking about. So when and then this is the really this is where the question gets interesting, because when we say what kind of clients, what do we mean? Either we talking about clients that like to you know say do X versus do Y? Is that how I define my profile, or how? So in this case, we are defining a profile of a client by job, marital status, education, etc. We are also looking at risk. We're looking at existing loans. We're looking at campaigns or contacts that have happened with the client, right? Where how many days has it passed since we have contacted the client, and those kind of things. So these are some brainstormed attributes that have, I'm sure people would have brainstormed it. I'm sorry, who, what was, okay. So people would,
Can you keep everyone to mute from your end?
hang on.
one question here in this data set, right? So where this problem is, okay, we are contacting someone for a loan. It may be
Yeah.
something is known, right? So there would be a domain where we don't know much, right? And
Not can one of you please help me? Can one of you help me mute everyone? Can all of yeah, unless except for the person speaking, may I please request all of you to go on mute? I'm not sure how to do it myself. I'm trying to having a hard time doing it. Uh, okay, I think yeah, people have gone on mute. Sorry, come again with your question, please.
yeah, so when the domain is unknown, those feature engineering techniques, those
Hmm.
correlation, how much they would help? So should we start with there? Or?
They will help, but you need to. So say you have 10 different tables, right? Each table has 2,000 attributes. Like, do you make a master data set by joining all the tables? Not really. So you need to know where your starting point is. So I would say if it's an unknown domain, it should start with some element of research about the domain and some discussion where when the project is actually been given to you. So that is why, guys, and I think these are last 2 3 questions have been very helpful for me, because it has prompted me to like talk about a few things here. So the first thing I'm going to talk about is that as a data scientist, never be under the impression that things will be prescribed from a data perspective. Okay, so it is an expectation that the data scientist is going to be also acting like an internal consultant. So there can be an external client and there can be a front facing consulting team, and in the same company, say you're working in the analytics division or the machine learning division, where you're working with the consultants, right? But all of you should start right from today, think of yourself as data consultants first. So you need to ask questions. So if it's an unknown domain, I would say the way I would start is simply by asking questions to the person who has done this kind of work, or how was it done last time. So if there is a marketing campaign, so imagine this. I mean, if say telemarketing never existed before, then we would not even have this data set, right? The fact that we have this data set means that telemarketing campaigns have been going on for quite some time and data has been captured. So today what we want to do is we want to use that data set and we want to come up with insights, so that next time around we have a strategic advantage because of the data that we've looked into and the insights that we've been able to cover. With me so far? Right? So if
Yes,
you
yes,
there
yes.
has to be some instance, some in the history, this would have whatever you're working on, it has to be historical for you. Things need to happen. So for example, if you're so imagine this. I mean, if say you're setting up a brand new channel and there is no past performance or past historical data on it, you cannot do machine learning. And this is where um, when people get into data science roles, the expectation is slightly different, that there will be projects problems to work on. No doubt there will be, but then there is a strong element of business development which is not talked about in interviews. Trust me, guys, that's the unexpected part, and that will come to you when you start working on different projects in your teams. It will come to you, and when it comes to you, it is not going to be easy because there is no past data to look into. So all you are going to rely on business hypothesis, and all you're going to do is either reach out to different people, start connecting, improve your network, start understanding the domain better. So these are very, very important attributes. But yeah, there is no initially, if you have no idea what's going on, you should just ask questions, and also ask how many times have you done this sort of campaign in the past, right? So in the past, what's been your strategy? What kind of people do you normally reach out to, and what is your success rate so far? These are very strategic questions, important questions for data science people to ask. Okay,
Hi,
well, I hope
everyone.
that
There's one
clarifies this.
question from my side.
Okay, yeah,
Can you
please.
hear me? Yes.
Yes, I can hear you.
Yeah. So there are different type of variable you have included here, right? So loan, housing loan, and all, you can find the data from bank, right? But the campaign duration and all, they are bit different, right? So some marketing people, they can give that data. So I am trying to ask here is
Bank
that there
bank
would be
keeps a track
different.
of no, bank keeps a track of their own marketing campaign data.
Yes, yes, but market I am trying to ask is between those two variables, there would be time gap, right? So when asking about the marketing data, the marketing people will try to collect the data in different time, and loan data will be in a different time. So I mean to say,
Mhm.
some another variable will be collected in another time. So
Yes.
how to coordinate between them and how to correlate it, how they are affecting the overall
So
model.
yeah, like I said, I mean, see, this is an example data set. Of course, there, when you, uh, no, actually, I would beg your pardon. I tend to disagree, and I'll tell you why. The housing loan and the personal loan are categorical variable, no doubt. Absolutely, they're categorical variables. But it talks about whether the person has a housing loan now. So when the data set is getting ready, when the data set is getting constructed, in that at that time, is there a housing loan going on? Is there a personal loan going on? It's not at a different time. Say you are building the data set today, only today. So as of today, you pick out all these features. Okay. Now, as of today, you start calculating based on the last contact that I've made, how many days has passed. So you calculate P days. Similarly, previous number of previous contacts performed before this campaign and for this particular client, right? So how many times have you reached out to this client? What's been outcome of previous marketing campaign? Is it a failure? Is it a success? So previous marketing campaign that you've done, have you been successful? Like, is the data captured in the database? Assuming that your database is very robust and it captures things well, you can then have a result also, that okay, let me see last time when I contacted, what was the result. That's why you have the outcome. It's the employment variation rate. This is also slight coming from economic factors, consumer price index, consumer confidence index. So you want to make sure that you are giving out a term loan, right? This is a product that is related to the economy in a long way, right? In a huge way. So if people, what's the level of employment that, that's important. Then consumer confidence, number of number of employees, etc. So uh, these are variables that will tell you that overall, from a social and economic perspective, what all is going on. So this is what got added to this data set in order to enrich it further. But coming to your point, it is, these variables are not taken at different time points. You are supposed to take all variables at a certain time as of the data building date.
Okay, so the time frame should be fixed for time frame should be same for each variables, right? Then you can predict anything. Else it
time,
will not.
time frame can be different, but as of when, that should be same.
All the variables should have the same time frame. I mean to say,
No,
under
okay, if you mean,
let's say all the variables are collected in a same month. So
yes, yes,
the,
yes,
the
yes,
data should be of the same month, right?
yes,
And
yes, yes.
if they differ, we have to
Collected as of same month, it may not be of the
yeah,
same
yeah, yeah,
month. Yeah.
yeah.
So for
So
example,
say
you are collecting, say, you can have, say, forget about these variables, right? You guys can have things like, how many contacts made in the last 6 months. You might want to have a better defined variable. Say in the last 6 months, how many contacts have I made in the last 3 months? How many contacts have I made in the last 9 months? But what do I mean by last 6 months? Starting from today, going back in time, 6 months, right? You see what I'm saying?
yes, yes,
Yeah, as of now. And that's a very important, this is relevant for all of you guys. This question, I cannot stress on this enough. These are important questions because they talk about the data, the initial data building perspective, and it's important to understand how to structure the data. All of your success or failure it is going to depend on how you structure your data. So you have to have full understanding of what's going on here. So the first thing you will do is you will start your analysis on a certain day, any given day, right? Now, either you choose to take that day and then start measuring the last 6 months, or you just measure that, okay, I'm in the month of July, that starting from 30th June, and then I let me go back 6 months. So 1st of January to 30th June is my 6 months. right? I measure how many times people have been contacted, etc., and I build my data set.
One
Okay.
question here. Now, suppose we are going to take the problem statement, this particular case study, at this point of time where we have a COVID-19 going on.
Yeah.
Okay, now if we see the actual data at that point of time when the loan was given or whatever, the situation was different. We cannot compare that with present situation. Now, even,
No, you can't.
right? So they're not like, yes, there is an additional variable or something which might be coming into factor now.
Yes. So COVID has impacted everybody.
Yeah. So, okay, my point was
Yeah.
because of this COVID, I don't, even if I really wanted to take loan, now I don't want, whatever reason. I'm just,
Yeah.
most of them are doing that,
No,
right?
absolutely. And this is a problem. This is a real life problem all banks are dealing with. I am dealing with it, right? I'm trying to build visualizations of my portfolios that I'm working on.
Yeah.
I can tell you. So yeah, so what we are doing is like very simple. Like, we are trying to come up with some sort of factors that multiplies the effect. So we're saying that the last 6 months is also divided into first three, which was probably equilibrium, and then after that, from March onwards, April, May, June is where things went downhill.
Hmm.
And so we are trying to sort of benchmark. People will, so if you find yourself in this year, say in the month of September and you or October, and you want to see what's happening from a COVID perspective, and then try to predict for the next 3 months, like until December. So what you would do is, you will have to factor in for COVID. I mean, you can say that, yeah, say for, how do I put it? Okay, so if you see jobs right now, you will have to see the default rates in different jobs or success rates or failure rates in different jobs, and that would have changed between 2018 and 2020. So in 2018, somebody with a entrepreneur kind of job category would have taken a, every time you call up, so out of 10 times you call up, there's a success registered 3 times. That's a huge success rate. But the same category might have suffered a lot of losses due to COVID, and then the person is not in a position to take a loan. Then that is important to understand. So you have to look at the shift in the behavior of the population, and you have to modify your analysis accordingly.
Yeah.
You've got
So, yeah, I got it. So it looks like if it is not it's a non-COVID, suppose now, the prediction will be quite accurate. But because of COVID, even the prediction might be wrong.
it will be wrong, absolutely wrong. I mean, very, very wrong.
Very wrong. Yes.
Yeah.
Okay. Yeah. Thanks.
But prediction is going to be wrong.
So
But
if we can eliminate this,
allow me to finish. So if the prediction itself can be wrong, but the direction will still not be wrong. I will show you what I mean in the next session when I do Python. But what I mean is, when you talk about prediction, you're talking about predicting the class, right? So predicting whether this guy is going to take or no, yes or no. Like you just you're saying, okay, there are two class that defines the universe. Either you're going to be like accepting a term loan or not. So predicting which class you belong to, you would as a client you're going to belong to. So that prediction is going to be super, super wrong. Understood. But will my probabilities also be wrong? Maybe,
Yeah, that may not be impacted.
may not be
May
impacted. But
not be.
so what will happen is this, a person who has 90% chance of term loan will now have 60%. A person who had 30% chance of term loan will now have 5%, something like that. But the 30% will not become the person, a client who never had a high probability of taking a term loan in a pre-COVID scenario will not become a uh, high likelihood case in a post-COVID scenario. Everything will go downhill. But then the sense of direction will still continue. The ordinality in the probabilities will still maintain. I don't know if it made sense, guys, but did it make sense? So
Yes, yes.
Yes.
you had 90% earlier. You are not now going to have a lower probability. But compared to you, somebody was sitting at a 30% or 40% in a pre-COVID scenario. That person is also impacted by COVID, right? So
Right.
then in a pre-COVID scenario, if there was a low chance of you taking a loan, it will be even lower now. So from a ranking perspective, you will still sit higher than this other guy in terms of likelihood. So directionally you are still okay. If you must run this campaign, if you do not have an option and you must run this campaign, then you have to sort of look at that direction and then carve out your population that you want to prioritize on. You can still do that. You see what I'm saying? If you still want to invest money in the COVID scenario and run a campaign, then you can do that using the probabilities, using, because the directions are going to be still okay. And that's what we'll try to do to carve out a strategy. I mean, basically, it's not the only thing, but I do want to leave you guys with a sense of what we can do. So shall we move on to the?
Sure. Yeah, let's go. Thanks.
Okay. So uh, I'm going to just outline a few steps that I'm sure all of you would have known by now if you've gone through it. But from a process outlining perspective, it's important to call things out. So we'd say we'll start with some EDA or exploratory data analysis. So the way to start doing this is try to understand it things variable by variable, and try to see how well populated the data is. Okay, so okay, and then start by looking at how much variation. So it's important to understand that if any variable does not have enough standard deviation or variance in by itself, cannot become a good predictor of any outcome, right? If it only takes say one value or two values, then that's it, right? I mean, if you do not have enough different values in a numerical variable, or say if it's a categorical variable, then it has to start capturing event rates differently across categories. And if that's not the case, then if you have, say, imagine a categorical variable that takes four values, A, B, C, and D, and then for each of the values, you've got only every value takes 10% of event only. Like in whatever value you choose, you get 10%, right? So you can't really predict anything with that kind of variable because it doesn't matter. You can just close your eyes, pick up any category, you're going to be as good as others. Like you're just going to be 10%. It's not like you pick up, say, category B, and suddenly instead of 10%, you are 30%. You see what I'm saying? So there has to be some variation. Then unique levels for categorical variables. So we know from the data description what unique levels are there for categorical, but it's important to explore what's the missing percentage for each of these categories. Where are what is the event rate across all these categories. So these steps are important. What I try to do is I try to discard variables that have more than 25% missing values. And I'll tell you, this is my perspective, and this is actually developed with a team, with my team, is that we don't believe that any variable that has more than 25% can be reasonably imputed. And from a technical perspective, you can impute it like, yeah, there are ways, but with that kind of imputation, can you make a reasonable business assumption, and can you rely on those imputed numbers in order to carve out a business strategy? That's not very reliable. So and if you say, even if you articulate this point to your project stakeholder, I'm sure the project stakeholder will appreciate this, because you're trying to maintain integrity of the data, and you're saying that, okay, look, I don't know why a variable has 60% missing values, but to me it looks like that is not something we should use in order to carve something out, unless and if you think that's an important variable, your recommendation should be that in the next run of this model, why don't we make sure that this variable is actually populated. Make sense, guys? So you're actually, you're hitting two targets with just one discarding. You're making sure that your data, you're throwing away junk, but you're also coming across as a very thoughtful person and saying that, okay, this variable, if we get data for this, say for example, I'll take a simple example, client industry. It's important to know which industry the client is coming from. Okay, if these are, so in this data set, we are talking about individual human beings. They're working in different jobs, right? But if, say for example, we are giving out loans to different companies, we want to know which company operates in which industry, don't we? Now in that scenario, if you don't have a lot of client industries populated, then it is a problem. You cannot include in the data for sure, but you can always recommend to your business that, either we should buy data, with regards to all these company databases and make sure the industry is populated. Because if you do that, then the data will be enriched further, and client industry can become a very strong predictor for your next for the next installment of marketing campaign, right? So you're hitting two targets actually, one recommendation and also discarding. Then a simple method of missing value imputation can be mean for numeric, and then we're taking the model class for categorical variable. Should be simple for all of you guys. Any questions you might ask? Okay. Second thing I would recommend that we should do is bivariate plots. Now, this is a very interesting phase of the data pre-processing part of the project. What we are trying to do here is that we are taking a variable and then studying its behavior with respect to the event class or the target variable, right? Now, what will happen is we will have an average event given to us. For example, 7%, 8% is the average term deposit rate in the data. I'm assuming numbers here. Now, in that scenario, what you want to do is you want to see, are there pockets of your data? Are there, parts within a certain feature when you can see higher concentration of term loan deposit rates? So is there a set of clients for who the term deposit rates are, say, instead of 7 to 8 is say 21 to 25% or something like that? Yeah. So you're interested to find that out. How will you do that? You will try to do two things. One is that for numerical variables, you can try to group them into different ranks. So you divide your numerical variables into 10 ranks, 1, 2, 3, all the way up to 10. Each rank can be composed of, say, 10% of the data, also called deciles. And then across each of these deciles, you can try to see what is the event rate or the term deposit rates in this case, right? Or in case of categorical, you can see what's the deposit rates across different categories. So these will do two, three things. One is it will help you understand where does those, what is that subsegment of my data where I can have a higher term deposit rates. That's one piece. The other piece is that based on the term deposit rates and the related behavior, does it make sense to group some people? Like, for example, this will become much more real. So you have basic 4 years of education, basic 6 years, and basic 9 years. Now imagine that for term deposit rates, it doesn't really matter if these three things, if these three categories, they all have similar term deposit rates, then why don't we group them, right? We could have probably, if we try to group them, then do we still get a decent event rate for the combined group or not? But the combined group will be composed of um, more observations, so therefore the grouping logic can be also determined using the bivariate plots. Okay, the third thing is that what are the extreme values? So in case of numerical variables, sometimes, if you create percentiles or if you create deciles, you'll see that 99th percentile value, sometimes 90 percentile value. You can also um, okay, you guys can start. Just give me one moment. Okay, the baby is back with me. I think she's had enough of machine learning. Just give us one moment, please. Sorry about this. Sorry about that. Um, okay. Can all of you hear me now?
Yes.
Okay. So yeah, the other thing is that extreme values, right? So what happens is, um, it doesn't have to be deciles. You can actually group into 5% groups also. So every group can be composed of just 5% observations, and then you do a bivariate plot against each of those groups. You plot the event rates. Now when you plot the event rates, you might want to see whether whether each of these whether these points make sense to be capped and floored. So if you have suddenly a very extreme value, you might want to remove that or just take the value lower than that in order to cap it at that point. And also from a lower side, you can just floor it at that point. So this is an alternate way to cap and floor. Of course, capping and flooring standard way to do that is simply cap at 99th percentile and floor at the first percentile. Okay. But an alternate way to do capping and flooring is by checking on ranked plots. So or bivariate plots, where you might want to see at which point it makes sense to cap which variable. So not all variables should be pointed capped at 99th and floored at the first percentile. You might want to floor something at the second percentile, because whatever you have below that seems like a very extremely low value. Or you might want to cap something at a 95th percentile, because whatever seems above that seems like a very irrational value. So it really depends. So if you want to do that kind of deep dive, that is also possible through bivariate plots.
Is that outlier detection are you talking about, or?
Yeah, outlier detection, extreme values actually. So that is also possible through your bivariate plots for numerical variables.
And bivariate, okay, so outlier and bivariate, okay. Two variables, right? So I'm
Yeah,
detecting outlier
yeah.
in
So
one column, or that's the thing, or why it's bivariate, I'm just confused.
correct. Yeah. So you are actually sort of, yeah, you, what you're trying to do there is that between your capped and floored values, right? There should be such that now once you cap and floor things, the event rate should now become a smooth trend or a linear trend. And that's important for you, because you need to make sure that you get as much monotonicity as possible, so that your prediction doesn't suffer and your rules become much more robust. So what I mean is that from a diagram perspective, it needs to look something like this. Just give me one moment. I'll try to bring my digital notepad out. Just give you a little bit of example here. Okay. Just a moment. Okay. So yeah, what we have here is, can you guys see that? Okay. Now, yeah, say this is the minimum value. Okay, this is the first percentile value. This is the fifth percentile value. This is the 10th percentile value, 15, all the way up to. Can all of you go on mute, please? This is the max value. Okay, of a variable, of any variable. So you have this as x-axis. Um, and then you have this as your y-axis. Okay. Now, when you're trying to plot, so you see that, okay, it starts with this point and it kind of comes down here, and then it goes up, and then it falls down here. Okay, so what you want to do is, you can see that between this point and this point, if you look at the trend here, it is a linear trend. Can you see that graph? So between this point and this point, the event rate, you've plot the term deposit rates actually. Okay, can all of you see the diagram?
So why
Yeah.
is the term deposit rate?
Because we are dealing with the term deposit problem. So in our case, event rate or event is, what is an event? Successful term deposit. That is an event, isn't it? Okay.
Is it plotted against time, or what is it against?
It is plotted against the values of the variable on the x-axis. So if you have, say, a variable called, say, let's take an example. If you have, say, income as a variable, okay, for 41,000 people, you have different values of income. Now, what you've done is you've broken them down into different parts. You've said, okay, let me just calculate this kind of table. What's the minimum value? Then P1, P5, fifth percentile, and so on, all the way up to maximum value. Now you've got some values of income here. All right. These are all income values here. With me so far? This is something you've done. Now, all these values, they've come on your x-axis, and you now basically plotting against all these values the event rate. All I'm trying to say is that you need to try and make sure the event rates are as linearly distributed as possible. Now, if you see the graph changing direction at some point on the higher end and on the lower end also, then try to use that as a capping and flooring point, so that you don't lose out on majority of your data, but also after capping and flooring, the trend becomes completely linear. It's not a very difficult concept, guys, visually. Okay. Okay. Now, how do we draw insights from bivariate plots? Now, based on the nature of the bivariate plots, we determine optimal predictors and also identify variable interactions. So what you can do is, when you do the bivariate plots, you can try to see, this is an outcome here. So if you have, I think this is P outcome. Okay, this is an illustration. So you have.
So can I tell you something, like just one thing, like as per the bivariate plots from point of view, can I ask something?
Yes, please go.
Yeah, the thing is that rather than capping and flooring, like can't we bin them in a separate variable, like that can also be done, right? Rather than capping flooring.
No, yeah, it can be done, but we're not actually building a scorecard sort of a scenario here.
Okay.
But yeah, it can be done.
Okay.
It can also be done, but this is also one of those cases where one of those things where you can use a bivariate if you want to use it this way also.
This is a nice way of identifying outliers and extreme
correct.
values.
And
I
it's
think that makes sense.
this guys, I did not learn this in the university because we basically used mostly like 99th percentile, anything above that, anything below the first percentile is called a extreme value. So that's okay. Chebyshev's inequality is another mathematical way of doing it, but this way it becomes so visual. For even if you're presenting, say for example, you are suddenly encountered, you're presenting to a marketing VP, and this person does not know why you have chosen to cap it at, say, some value. Okay, this is, say, alpha and this is beta, some value. You're saying, okay, anything above alpha, I'm saying you should just replace it with alpha. Anything below beta, I'm saying replace it with beta. This person comes and asks you, okay, what made you choose alpha and beta? Right? And that can be like a difficult question to ask, because now how do you explain to him the justification of choosing an alpha and beta? Do you see where I'm coming from? This is where articulation will be important for you. Do you guys see where I'm coming from? So if you have something like of this nature, a graph which clearly shows that, okay, we have to make sure the relationship is as linear as possible, and beyond this point, if I cap it at this point, I get a linear relationship. That is number one. Number two, this point is so far away from my average value or the median value that it will not make me lose a lot of data. For example, if this point is, say, the 70th percentile, then I have a problem, because beyond 70th percentile you have 30% of your data, and that gets chucked away, and that's a problem, right? But if this is a 95 versus 96, 97, 94, these numbers are fine. Okay,
That makes sense.
okay. Now, why do I say that bivariate plots helps you identify optimal features? This is a example of that. So this is a P outcome variable. It's on the x-axis. You will see okay, this is a picture I've taken, and it's a pretty bad attempt. So now it says 0. It means not accepted a term loan. Okay, and 1 meaning accepted a term loan. So if you see this one, in this scenario, the acceptance of term loan is much higher than other groups. So you know that this variable can be interesting. This variable can be a good predictor because, you know, there is a part within this variable that helps me identify a population that if I target this population, that then my natural likelihood, the likelihood or the probability of getting the term loan successfully sold is much higher. Okay, so this is an example of what you will look at, you know, in bivariate distribution. So you should be able to sort of, you know, see this. Then with regards to interaction variables, you can also build cross tabulation. So if you have, say, this variable p outcome, it takes 3 values. I'm calling it a, b, c here. Sorry. Just to explain. So you have a, b, c here, and then you have another variable which takes x, y, z there, right? So you can have a simple cross tabulation of 9 values, and you can find out which pockets the percentage of term loan acceptance is higher. Okay, you can see that. Okay, guys, all of us are on the same page here. Okay, all right. So now post all of these steps are done, right? So you will pretty much be done with creating different features, analyzing your data, deriving insights, and by this time, you know, your story there, your machine learning story is also developing side by side along with your data story. So when you present your findings, right, there has to be two kinds of story that you will come up with. One is your data related story, where you're going to present your findings in such a way that justifies every action you take later on. That should lead to an ML story, because, you know, whatever data story you have should lead to what you're doing with regards to your algorithms, and that's what we're moving to as a next step. So what I'm going to do is I'm going to suggest that let's take an approach in which we choose one classifier from a statistical family and we take one classifier from a purely machine learning family. Okay. And for illustration purposes, you can have n number of classifiers that you want to test out. That is perfectly okay with me, no problem. But in order to illustrate a solution to this problem, I would just do one from a stats group and one from a ML group, and then we can test out the results, and then it can be compared for final deployment. Okay, so if I take from the stats group, I would take the logistic regression algorithm because it's a wonderful classification algorithm. It's been around for a long time. It's still around very strongly, and many organizations rely on the outcome of logistic regression to take very structured strategic decisions. So what does it do? It leverages linearized features to satisfy assumptions of logistic regression. So all of you know that it's essentially the log odds on the left hand side, and on the right hand side it is a linear combination of features. So that's why ultimately the features have to be following a linear trend with regards to your event rate if you want to be successful in your logistic regression. What it will do for you, it will estimate the likelihood of an event, right, or the probability of an event using a certain link function. In this case, the link is logit. The logit link is nothing but event by your 1 minus event. That is the logit link. So log of 1 by 1 minus y, you know, that will be equal to some sort of linear combination of different variables. Okay. And what this does, this is the most important part, it creates flexibility because you have probabilities calculated. It gives you a lot of flexibility to create custom target segments based on predicted probability for each client. Okay, so that's what LR would do for us. When we look at a tree based algorithm, it's also going to solve for the same problem, or that is of classification. but the output is going to be very different, right? In case of a tree structure, we will have a combination of parent as well as child nodes. So parent node is where we have the entire population with us, and then when the rules are applied, then whatever we are left with is called the child node. Then it is important to understand that there will be no equation, right? There will be just a set of rules, no equation like this. So we don't have a equation like this. We have a set of rules that will come out from the trees, and it can be visually interpreted. So the ease of interpretation is much higher in case of a decision tree. So for marketing, decision tree is like God. Okay, so marketing analytics loves decision trees. They also love logistic regression model, but it's not like the hardcore probability that they love. They want to finally come down to segments using those probabilities, or audiences that they want to go after. That is the part, that is what I'm going to talk about and try to illustrate about the strategy that I was talking about. So marketing really likes visual outcomes, easily interpretable outcomes. That's important for you guys to keep in mind. Now if you're working with risk, no worries, you can go as technical as possible. People happen to know each and everything about machine learning, mostly in the risk community, so you should be good there. Now, based on classification capabilities, strategies can be designed on the ML tree rules to derive the optimal business benefit. It's important to understand this because, the tree itself will give us so many insights visually, and it can help us figure out those set of things that I pointed out here. So, even if you don't do all these interaction variable steps, if you say choose to so skip it, right? For a decision tree, that's fine, because the decision tree will automatically say if this variable is a good variable, it will say this is v1, right? This is v1, and say this is v2. If v1 v2 are both important and good, it will pick up v1 and v2, and you will start to see that, okay, this group and this group is where there's a higher than average term loan acceptance. If the average term loan acceptance is say 7%, then probably this group is going to be say 21%. I'm just assuming this is probably 35%. So again, assuming, so 3 times, 5 times the average group. So this is automatically going to come from your decision tree if it exists and it matters in terms of discrimination. Make sense, guys? This is all something you've all gone through decision tree. This is just a quick recap, but I do want to contextualize this in the um, problem that we're dealing with in the project that we're working on. Questions so far? Okay. A little bit about both the methods. I'm sure again it'll be a repetition of what we already know, but
Sorry, one question
yeah, go ahead.
regarding EDA. So why we are not checking the correlation between the things and like distribution of the variables? Like we should, right? We do only univariate and variable. So
Mhm.
in that, you will do correlation check and distribution of variables is not important.
So distribution of variables are going to be important. So when you say distribution, do you mean how the values are distributed over the range of variables?
Yeah, no, my distribution means is they're following normal distribution or not, because actually right, machine learning algorithms, it no, doesn't follow
Hmm.
a particular distribution. Like assumption is a normal distribution. That could be a problem, right, for predicting things.
Uh,
So
yes. So of course, it's a problem for prediction, but it's also true that we know from central limit theorem that we almost all sample sizes that are taken, all sample sizes, large enough sample sizes, they asymptotically tend to normal distribution. Okay, so we are dealing with a sample size of say 41k, 40k, for little more than 41k. So this is a large sample from a pure stats perspective. So you can assume normality here, but we don't really explicitly check for normality. It's not required in this current context. And then the other thing is about correlation, right? So you can see over here we are also solving for correlation, because if there is a variable, yeah, like in this case, so if you have an increasing trend, we know that this is going to be a positive correlation. Okay. Now, had this been a decreasing trend, we would have known it's a negative correlation. So again, across the values of the x variable, if the event rate is falling, then it's a negative correlation. Across the different values taken by the x variable, if the event rate is increasing, we know it's a positive correlation. So we in a way know that what is going to be the directional correlation. And this is also very helpful, because if you build a logistic regression model, right, you have this variable in your model, you will expect the regression coefficient to have a plus sign in case your graph has a positive slope, or you have a positive correlation. And in this case, you need to have a negative sign in the regression coefficient. This should tell you that, yeah, the regression coefficient should have a negative sign. So this is the other way in which you can use the correlation insight. But the insight is that an increasing a positive slope, it has a positive correlation. Negative slope, it's a negative correlation of the variable.
Is it like we can also derive from positive correlation is that there could be more possibility of detecting loans, and for negative correlation
Yeah,
of a
yeah,
variable with our independent variable, so dependent variable. So we can assume that okay, it's for negative correlation, that this variable is not like more giving like opportunity for loans like that. Can we draw some kind of conclusion from the positive and negative correlation?
absolutely. You can draw, you're bang on. If it's a positive correlation, you know that with increase in the variables values, chances
Mhm.
of picking up a loan increases. That's what you know. And also in the opposite side, when it's a decreasing curve, you know that as values of a certain variable increases, the chance of taking a loan decreases. For example, let's imagine that you have a variable like number of uh, number of defaults, or say number of times late in credit card payment. Say imagine that you have that variable and you are doing this exact analysis. I'm sure you will see that there is a positive correlation with regards to that variable. Why? Because this person happens to be very credit hungry, so if you offer a term loan, the person will take it. But obviously you will not, because the risk factor comes into play. But if you it means that uh, the greater the number of lateness in payment, the bigger is the chance of a person taking up a loan, because the person actually is credit hungry, and there is a lot of demand for credit. But it's a business decision not to go, you're not going to be giving the loan to that person. But it's just an example. So if you see a positive trend, you can interpret it that way.
Besides, also, like, do we need to really see whether the normality of the assumption when we are
No,
using a logistic regression or tree-based algorithm?
no,
We don't
not
need, right? Yeah.
no, we don't need it. And I'll tell you why. Because see, there's the dependent variable, right? It is actually coming from binomial distribution. Okay. Now, why is it important that only one thing is important, that you need to make sure that your
Linearized, yeah.
yeah, they are linearized. That is important. So your event rate becomes, it follows a certain pattern, either increasing or decreasing pattern. That is important. Otherwise, what will happen is, more than normality, this is the basic assumption, that whatever you have on your left hand side is nothing but a linear relationship of what you have on the right hand side. So keep in mind that it is ultimately a linear model with some treatment. Okay. So I was asked this question by EXL, that can you prove that all models are linear models, and also prove that all models are not linear models. So in an interview setting with a few seconds to answer, it can be a little unsettling. Then I realized that, okay, he's talking about the link function, I'm sure. So this is how I positioned the answer. And I said, look, ultimately, we know that not all models are linear, because, you have this, all dependent variable do not come from a normal distribution. It doesn't have to be a linear model. But in order to achieve linearity, we have link function. And therefore, when you apply link function, any regression equation can be made to form a linear model at the end of the day. So that's how you try to sort of link between the two, and you can get your job done through LR. Okay. Now, in case of tree based, a couple of things are important, like entropy. What's the information gain across different nodes? Then what is the level of impurity of a certain node? Now we know that in case a node has 50% chance of taking a term loan, 50% chance of not taking a term loan, it is going to be purely impure. And then based on these two, classification will happen. Ultimately, classification error will be computed. All this is automated through sklearn, so you don't have to worry about the programming behind it. All you need to do is make sure that you get the output, you interpret the output, and then move to the next stage. So we have a hard stop at 5. I am uh, at this. Let me just check. Do we have any questions which are pending?
Orito, I have one more question. That is,
Yeah.
in this models, we don't look for multicollinearity, right? Like when we have so many variables, like in the plethora of
Yeah.
variables that you've shown me,
Yeah. Yeah.
like will multicollinearity will not be a problem? Well, like won't we check for multicollinearity? That's what my
Uh,
question is.
yeah. Ideally, see, you should be checking for multicollinearity because you might have a lot of interrelated variables. So for example, in this data set, we may not have a lot of multicollinearity, but if you think of the one that I came up with, right? So here's the thing. If you just follow my screen here, I'll tell you under what circumstances you have to look at multicollinearity. So if you're, say, building a variable which is number of contacts in the last 3 months. Okay. Second variable is number of contacts in the last 9 months. So people who have been contacted in the last 9-month period would have definitely been contacted in the last 3-month period, right?
Yes,
But
yes.
it is possible that they may have been contacted between the 9th month to the 6th month, and in the last 3 months they may or may not have been contacted, right? So if I go back, say I am where am I'm in October, right? So from Jan to September I'm talking about, right? So from July to September, so this is my 3-month period. From Jan to September, this is my 9-month period. Say last time I contacted was in March and I stopped contacting. So Jan, Feb, March. So what will the value be taken? 3, right? For this variable, because Jan, Feb, March are 3 months in the last 9-month period. Then in the last 3 months, have I contacted? No, it is 0. So to that end, there will be like no 0 is not in this case it's not a part of 9 months. Now if you are contacting every month, if this guy has been contacted once every month, now if this number takes the value 9, then this number must be 3, right, isn't it?
Right, right,
Right? So in this
right.
case, it is correlated, right? So there will be some correlation, but if you are creating, say, derived variables like this, I'm sure there will be some element of correlation. So keep one of them, or you can try to create a composite variable. For example, you can say that, okay, how do I, okay. So you can say that number of contacts in last 3 months divided by average contacts last 9 months. Okay, so you can create a variable like this and get rid of these two, because this is a derived variable from these two. So what I try to do when I remove multicollinearity is that I try to create a derived variable, a composite variable, of which both of, like, I can take essence of both of them and don't lose out on a feature completely, but create a derived variable like this, and get rid of all these other issues related to collinearity.
This makes sense.
Okay. Okay, so this, I'm sure, like, you can get more content on the internet also. So let's not spend too much time. This is a completely known slide to all of you. I have it here just to make sure that if people are, just for the sake of completeness, that you create a confusion matrix. look at actual class and predicted class. In this case, to the gentleman who pointed out the COVID scenario issue, I'm sorry, I think I didn't catch your name correctly, but can you please call out your name? So thank you for that question you raised, that during COVID, the models are going to be mostly incorrect. But in this case, the confusion metrics for the COVID scenario, I'm sure it's not going to be looking as good. Similarly, accuracy, etc., are all computed from here. So precision, recall, and then finally the F-score. So these are standard techniques from a classification perspective that you will look at a model and determine whether it's kind of going good or no. Okay, so thank you for that question earlier as well. Now, let me come to this point where I talk a little bit about how we can enable strategic prioritization. And this is where I want to spend the last 15 minutes of time giving you some glimpse of what we can actually do. So imagine that, you have your data set, you've got all your variables here, x1, x2, all the way, you've got n number of variables. And then you have probability of event. Now this has come from your model. This probability has come from your model. And this is there for all the customers that all the data that you have. So you've got this for everybody computed. Now, for the telemarketing team, it doesn't really matter. They want to know custom lists and custom audiences to go after. What you can do is you can look at some features to develop profiles. So for example, you can start asking strategic questions that how does a client look like? So what's the job, right? Job level, what is the education level, what's the age level, right? And also what's the risk factor. If I can say, imagine that in our solution to strategy, what we will do is we'll come up with some of these parameters. So in your projects, in your roles in data science, you have to come up with some parameters like this, that let me define a target with respect to some parameters. That is number one. Okay, now when you do that, either you will have data in the form, like in this case job, education, etc., are given to you, like specific categories already mentioned, but age is not mentioned to us. It's a continuous variable, so there are no specific buckets created. So we might have to create buckets to determine which age group the client falls into. And also the risk factor. So can we use say some sort of, can we create a metric based on house loan, uh, any other loan, and also default? Can we create a metric like that? So if I can create a metric, uh, some sort of metric, composite metric based on this, and then use that metric to define my risk factor, then I should be good. So I'm taking some 3-4 category, some features to say that whatever I do, my audience is going to have some value related to these 4 features, defining their profile. Okay, with me so far? Not very complicated. Like it's like a Facebook profile. You've got your name, you've got your gender, you've got the country you belong to, what likes and dislikes. Say these are the 4 parameters. Cool. Okay, I'm assuming that to be a yes. Now, when we say prioritization, what we do is we take each, we slice and dice our data actually. So we slice our data according to job categories, and then we see that, okay, there are 5 categories, right? And in each category, I can calculate top X% probability based on my probabilities. So I have my probabilities over here. I can always say I'm interested in the top 20% people, like get me the top 20% people. So what I'm going to do is, then I will say, okay, for job A, who are the top 20%? For job B, who are the top 30%? I can get that, isn't it? I can get some sort of flag. So say So if you're top, say top 10%, let's just assume 10. Now, if you are top, if you as a client belong to that top 10% group, you get a value 1 or you get a value 0, right? Now, if say, if somebody belongs to group B, and then over there also, whoever belongs to group B, they can be rank ordered and classified into top 10% and bottom 90%. So if you are in top 10, you get value 1. So in your data, what you do is you do transpose, we call it transposing in SAS terms, but you can do one-hot encoding and just do it like that. So if somebody is in group 1, so the rest will be 0, right, for one-hot encoding. Somebody is in group B, the rest will be 0. Question is top 10%, 1 or 0, right? Question mark. So you say, okay, you belong to job category A, not a problem. Let me see. In terms of top 10%, you are a top 10%. Good news. So you get a value 1. Now, you as a client, you belong to group B. Okay. But are you in the top 10%? Unfortunately, no. So you get a value 0. Okay. So you can then count that with regards to job, like, how many ones and zeros are there? Quite simple. That can enable you to figure out that within each job category, which one should you go for. Then within your education, similar approach you can take. Within your age, you can also take similar approach, and that will help you do some prioritization within each group. Okay. So if you happen to see that, okay, this is my job A and basic education list with people belonging to 25 to 45 years age group with risk factor low, something like that, right? So uh, in that kind of segment, you will see, okay, these are my top 10 guys, these are my bottom 20 guys, so let me go after them. So if you happen to be top 10 in all of these 4, you will have the value of 4. If you're not top 10 in all 3, all of them, if you're in 3 of them, you will get the value of 3. You get the value of 2, or you get the value of 1, or you get the value of 0 throughout, right? These are the possible values that you can take with regards to all these features and parameters, isn't it, guys? Yeah, is it making sense?
Yes.
Yeah.
Okay, so then what will happen is you will use your machine learning model to get to what, if you just follow my cursor, to get to the probability of event. That's all. Then break it down into a format which is easily understandable from the telemarketing team's perspective, and then very simply actionable. So make sure whatever you do with your machine learning model, you can sell it to a person who has even not even heard of, or maybe just heard of machine learning, and that's it. There's nothing to, like, there's no reason for the person to say that, okay, I don't understand your work, and therefore I don't think you can implement it. Don't let that happen. Make it understandable by what they understand. So everybody will understand what this profiling is, right? Every business person understands profiling. That much is guaranteed. Absolutely. Everybody knows who their customers are, or if they don't, they would want to know who their customers are. So every business person is in the lookout for that one answer. Can you tell me who are my best customers? Very simple. Like, you can obviously start automating it and build a classification model, and it can tell you that, okay, this is your good customer, yes or no. That can happen, but it will be a black box solution. The person has to completely trust you. But in order to gain their trust during your initial days, this is a very good way in which, I mean, this is an example, guys. I would encourage all of you to think on these lines, come up with your own when you practice on this problem on your own, come up with your own solution and own recommendations, so that when you talk about it in your interviews, you're going to simply say that, look, the way I approach this problem, it is not only from a purely ML problem, technical issue. So it's also outside of this technical issue. I assumed a real life scenario in which I thought of myself as a data scientist working on a live project like this. Then what would I have done? This is the thought process value that I bring to the table as of today. And then the argument during the interview is that, look, this is still a scenario. This is the maximum I can do in terms of working on a data set available on Kaggle or UCI, and then apply my limited understanding of the business with regards to strategy. I'm looking forward to a similar opportunity in your organization, where it would make sense for me to get gainfully engaged with you, so that I can start developing more of these and then learn from you to become better at this work. So your objective that should be that in the next 5-6 years you should start to see yourself move a little bit away from hands-on to say directing or managing multiple projects in which people are working with you, where they are developing solutions, and you reach a point where your thought process is so strong that you can actually direct 2 or 3 projects at one go and manage the show. So that should be your, I would say that should be the vision for you, each one of you. I'm not sure where each of you are in your data science career stages, but yeah, that should be the overall journey there, aspirationally. So okay, so with this we then come to the end of phase 1, where I have walked you through the data, giving you the sense of what kind of variables to expect. I will immediately upload this on the April 2020 drive. And I'll try to get access to the LMS Learn Vista, and then try to sort of upload there also. Now the thing is that please look into this, use this as a guide for working with the data, try to come up with your own solutions. I am going to be again coming on next Sunday at the same time to present my solution on Python and to present an example of a strategy to you. So that should serve more of an example in which you look at it and then always refer to it. Maybe you might want to try to replicate it. That is perfectly okay, but do not restrict your thought process to only that. I would love to see this project encourage you to think more and start getting those ideas where you look at a different project altogether, not this, but at least start thinking in these lines that okay, how can I take the outcome? So wherever Kaggle notebooks, you will see a lot of notebooks in Kaggle, so they would kind of stop at the stage where they reach a certain accuracy, certain RMSE value, and they kind of most data scientists would stop there. But please try to go a few steps ahead and just ask yourself that question. If I have to explain this to someone who does not know anything about machine learning but understands more or less something about the business, what can I do with this data in order to further my agenda? So I'm going to take a pause there to see if you have any questions, suggestions. Did this make sense, guys? I'm open to hearing what you have to say.
So Ritu, A, B, C, D, these are all the features, right? I mean, on the basis of which I'm evaluating a customer.
Yeah.
Right.
So this could be either think of them as individual features or think of them as individual levels within each variable.
Right, like job, education, age will be like A, B, C, D, something like that, right?
Correct. Yeah. So job can be 5 categories of job, 3 categories of education. You can divide age into like 10 categories, or maybe not 10, 5, 6 categories, right? So you're trying to define your audience. Just definition of your audience. You defined your audience, then you say within each definition, I want to choose the best, and I want to go for the best of the best first. So the four ones are going to be like targeted first, 3 ones are going to be targeted second, third, and fourth. It's a 4-week campaign. Job done. You've prioritized, you've strategized. 4-week campaign. Week 1, go for all the 4s. Week 2, go for all the 3s. Then week 3, go for all the 2s, and whatever is left, you go for them. But you go for the best ones in the first attempt, so that by the time you reach week 3 or week 4, you start getting responses from these guys, and so you start justifying some of the money you will be spending in the telemarketing campaign.
Right.
My question is, how you define best in this case? Best customer?
I just said, right, top 10%. Top 10%.
Yeah, like top 10%.
Top 10%
Example.
based on the probability of event. So probability is between 0 and 1, right? So what do you mean? So say, for example, somebody can be 0.8 probability, somebody can be 0.3. So which guy is a better guy? You tell me.
Yeah, 8 to.
Correct. So when I say top, I have a lot of people, like 41K people will get 41K different probabilities. So I am interested to find out those top 10%. So like in my entire data, top 4,000 people are going to be my top 10% data, right? So imagine that 41,000 students have scored different marks in physics. you're interested to find top 10% across the country. And this physics Olympiad is taken only by 41,000 people. Yeah, unrealistic number, but still, just think about it like that, right? So there's a Olympiad exam that happened, and 41,000 people have taken it, and then you're interested to give certificates to only the top 10%. So you just be like 40%.
Sorry to ask you again, how to find those probabilities?
How to sorry?
Probabilities, you said probability, right? You're
Yes.
saying you have to find out probabilities.
Yes.
How to find probabilities?
Oh, okay. How to find probabilities? I'll explain. So just use predict dot prob a. Take all the rows. Take the first column. Oh, sorry. Yeah.
In
Okay.
last year, right? You're talking about?
You will get use predict underscore prob a. Okay. You will get two columns in your pandas data frame. This is the 0th column. Drop it. Take the first column.
Okay.
So these two will add up to 1. So if it's 0.2%, 0.8%, 0.3, 0.7, 0.9, 0.1, and so on. Okay.
This is the final step, right? After the model is done and all that.
After the model is done. Yeah. After like just the model fitting is done, you're like happy with the performance on the validation data and everything. So that's when you do. So I will not go through each of the modeling steps. Obviously, I will have the code ready with the outputs ready. So the time consuming parts of the code I'll not go through, but I would I mean I try to go through in small detail, but we'll spend some time building some couple of strategies to sort of see how do we evaluate them, etc. There has to be some way to evaluate them, so we'll have to just think through on those lines.
So is it like we have to do all this kind of models, these two step, like characterize and paradise?
I'm sorry, I didn't understand the question.
Okay, so my question is like we have to do this like all the classification kind of models, this paradisation step. So we have to do it will applicable for all kind of classification models.
No. I'll tell you why. If you are building a risk model, anything which involves targeting people, okay, anything which involves certain action that the business have to take with respect to the model output, then prioritization is important. Okay, so if you're reaching out to a customer with a new offer, that at that time prioritization is important. Otherwise, if you're like, for example, if you're simply classifying, if you have an automated decision system where a classification is if you create a classification logic, and then based on the classification logic certain decisions are automatically taken, that's okay. You don't have to prioritize. I mean, you don't have to build a strategy like that. But if you, in case of especially in case of marketing, in case of customer management, customer engagement campaigns, how to expand or customer acquisition campaigns, how to increase your portfolio size, these kind of issues, these kind of business interventions is where you need a prioritization aspect. Does that make sense?
Yes, yes. One more curious question is that isn't that your clusterization will help you in this case?
So sorry, your voice is
Uh,
echoing.
Clusters.
Clusters, no,
Yeah.
clusters can help you. So if you want to say you have these 4 variables, if you want, by all means create a k-means cluster, create 4 clusters based on these 4 variables, 4 or 5 clusters.
Yeah. So will it help you in this case?
No, it will. Yeah. So there is like absolutely flexible. Like you can have 4 5 features, and you determine that okay, out of these 41K universe, no, I will create say clusters, and these clusters are going to be like segments of customers, obviously homogeneous within the group, and then heterogeneous or different across the group. So you can do that, and within each group you find out. So all I'm saying is find a way to define your universe and find a way to segregate the universe. So ultimately it comes down to define. Okay, Then it comes down to slicing of universe, and then you pick your targets. Define your universe, slice your data, pick your targets. Okay, guys, so I have a hard stop now. Um, I have to move on to the other project management because my wife's gonna get busy. I have to start minding the baby. If you have any more questions, please reach out to me on WhatsApp. I have my number given on the next slide. I'm pretty responsive on WhatsApp. You should be able to get a good response. So I hope this was useful. It gave you some sense of direction towards how a project features a purely machine learning data set given an internet available to all of us for use can be used to sort of create some sort of marketing strategy and then position it in our interviews. I hope this was useful to some extent.
Sure.
Thank you.
Thank
Thank
you.
you. Thanks. Bye bye.
Thanks.
Thanks. Bye bye. See you guys in next week. Till then, bye bye.
Yeah.